Hello, everyone. Welcome to me. And today is a continuation of last week. Last week, we were looking at creating blend shapes using the USD Python API. And today, we're going to wrap that up. So the reason that you would want to do this is, for example, you're writing a translator from some other DCC, Maya, Blender, or we have connectors for those for Omniverse. There may be another application that you may want to connect that has characters, and you want to be able to bring them into USD, into Omniverse. You want to be able to interchange them efficiently between different applications. So this is where you would want to look at that. Additionally, there may be some specifics to your characters that you may want to encode differently from maybe the way that the exporters in an application may do it. So, and then the other thing is it's just great to break this down and study it as far as how it works, so that when things go wrong or when things maybe change, you're able to debug it and understand what might have gone wrong or how to move forward. So we are going to pick up where we left off. Good morning, Data Juggler. If you're here, please let me know. I'd like to know who's watching and connect with all of y'all. So, all right. So we had this script from last week, and I ran into an issue where stuff just was not zooming, or it just wasn't displaying correctly. And what I finally tracked it down to, hey, Funky Boy, hey, Ruchi, what I finally tracked it down to was the extent. And now, in hindsight, I probably should have known that. But let's take a quick look here. So I just ran this. I think I ran it. Nope. Just in case. Let's export it again. So this is what I was getting, right? I could show the dome light, and it looked like that last week. What that came down to is, everything's there. It's drawing. I didn't get any errors. But ultimately, it looks like it's just very zoomed in. And so what happened is when I added the skeleton, it seems like the automatic extent, there's maybe some automatic extent calculation that happens, but when I added the skeleton, that was being ignored, or that was no longer working. So now when I run this and I give it an explicit extent for this mesh, I can reopen the stage, and there is my triangle. I'm getting a little bit of clipping on the camera plane, but that's okay. We're not gonna deal with that right now. Solution would be, let's see if this, it looks like it's automatically calculated. Is that better? No. Far. That looks better. All right. So another way to fix this is, use make a camera, give it the extents that you want. I don't know if this is going to hold up for after I reopen the stage. If it does, that's great, but I think it's going to recalculate it. it looks like it works. Cool. So we have our extent sorted out. Basically, I gave it the same extent as what I built it with. This is a bounding box. The minimum corner and the maximum corner of a bounding box. And then it is just good practice in general. I think that once I added that skeleton, there are notes about calculating extents for skeletons, encoding the extents on the skell root. And this is a good idea just because as these characters may be animating, you can, instead of, they may be made up of multiple meshes. So instead of looking at the extents for all those meshes underneath that are all animating and deforming, you could just have one bounding box defined on the skell root. That gives you the bounding box for the full character. So we won't get into that today, but just keep in mind that extents and is an important optimization for USD. So cool. So some other things to catch up on here. I added the skeleton. This was fine. Basically just a direct child of the skell root. Let's look at the hierarchy here that we built. So it's skell root, skell, mesh, and I removed the animation for now. This is what it looks like. Well, one thing I wanted to call out is you can define as many blend shapes as you want, but unless you add a skeleton animation, it's not going to change the shape, right? It's just basically extra data for the mesh. I also found the skeleton is required even if it's empty. So a lot of times when you build a character, you'd probably have a skeleton for the limbs and the general body motion, and then you'd do probably blend shapes for the facial animation. And so you'd have both. But in this case, if I had a mesh that I just wanted to animate with blend shapes, and it looks like the skeleton, even if it's not doing anything, it doesn't have any. I haven't added any unique data to this. It is required. So I think that is a good call out to add to the docs. And then I bound the skeleton to the mesh. You can look at that mesh. Skeleton is pointing to that skeleton. So you do need that. But you can put the binding on the skell root and it'll inherit down. So just an option there. And then like I wanted to, I put my skell animation on the skell root. So I have this animation defined. We're saying take this blend shape and set its weight to 1. And then we are setting the animation source on the skell root. So let's go ahead and run that and we'll look at that result here. We look at it here. So there is my animation source on my skell root pointing down in here. As far as where the skeleton animation goes, it doesn't seem like it's strict. I've seen some people like putting it underneath the skeleton, but it can be separate, and it can even be outside of the skell root. You might want to do that for instancing, but it's not a hard requirement either. But the reason that I was really insisted on putting the animation source on the skell root is because of the mention that if you want to instance characters for say crowds, but you want to instance one character but have varying animations between those instances, you have to have the animation source on the Skel root so that you can modify this relationship without breaking the instancing. If you have it any deeper, then you have to uninstance, and then that it completely defeats the purpose of instancing. The error from last time was that completely kind of related to Skel. I didn't have USD View didn't have a clear understanding of what the extent was for my skeleton, for my mesh. So I think the way that I solved it was defining the extent on the mesh, and that worked. Another way that probably would have fixed it is defining an extent on the root, on the Skel root. We could try that out if there's time at the end, because I am a little curious. But yeah, basically what was happening is USD View would open the stage. It had no understanding of what of the size of the stage and of what could be zoomed in on. So it just zoomed into something minuscule, and then if I tried to frame the mesh, it wasn't able to. See how I can frame on this by pressing F? That wasn't happening. So that's sorted out. Now we can move on. We have our animation. I'm going to reopen. I don't know if I ran it, but yep. So now we have the animation applied, and it's not animated, but it is referencing this anim prim, which is telling me that it has a static or a blend shape weight of the isosceles blend shape, and it's a weight of 1. So we get that isosceles shape that we defined. So now let's make this a little bit more interesting, and we'll define one more blend shape, and we will also animate between them. So we're going to create a blend shape here, and we're going to call this one right, as in right triangle. And then we're going to set along the X, we're going to go back half a unit, so that we go back and line up these 2 points. So we're going to offset negative 0.5 on the X. And it's going to be, I don't remember my indices, but I'm guessing it's 0, right? Yeah. Because that would be, nope, it's going to be 2. Right? 0, 1, 2. Oh, I'm sorry. No, it's 1 again. We're moving the top point, and we're going to move it to align it with the last point. So it is index 1 that we're moving. And now we're going to add one more of these. And it would probably be smarter to store all your blend shapes in a list, and then set the list here, and then set the prim path targets here from that list. But y'all are better coders than me, so don't do like me. All right. So no difference here, at least in the viewport. But we look over here, we've got 2 blend shapes now, and we can go ahead if we don't know the script language, how can we do it into Omniverse? If you don't know how to, so for USD, we have C++ and Python for USD coding. If you don't know either of those, today I would recommend try to stick with our connectors. So we have the 3ds Max, Maya, Blender, iClone, all of these applications that are where you are able to create character rigs and animation. We've added support for translating. These connectors will translate the data from that application into USD, and you should be able to get a USD. So you can have that should work for Omniverse. If you need to take it somewhere else, well, now you've got the USD file to take it anywhere else. I should also mention that we have in USD Composer and our other foundation applications a file format plugin, so you can actually just directly import FBX and GLTF. So those are two other ways to get skeleton and character animation data from common source into USD. So now what happens if we set our animation to use right? Right, we're just we're not doing the isosceles. We're not using that blend shape anymore. Now our animation is going to fully apply the right blend shape, and we get that right triangle. I'm not totally happy with that. I actually wanted it to be equal length on these sides. Should I mess with it? I have to get the offset. So it's like 1 minus equilateral triangle height. I know this doesn't matter in the end, but there we go. Okay, so there isn't just a motion to the left, it's actually also growing a little bit in Y. We'll see. I wanted to separate kind of the animation channels, but this is okay. So we just need a simple hello world blend shape example. The simpler the better, make it elegant. I think that's referring to my debate on whether to make it pretty or not. Okay, so now I can set both, right? I believe. Yes. Trying to go off of memory here. But I think I can say for this animation, this is default. So I'm not doing time samples yet. But for this default value of this scale animation, I'm going to set these values for both of these blend shapes, these weights. Hello, Omniverse from scratch. So now we should see a right triangle that's also stretched to a little bit more than the height of our original isosceles triangle, because we added the little bit of, I'm going to say just to, nah, I think this is fine. So now we have our original equilateral triangle plus the isosceles offset plus the right triangle offset, all blended together according to these weights. If I didn't want so much height on this shape, I could do a weight of half on the isosceles blend shape, right? And we get a slightly shorter shape there. And then theoretically, I can overdrive these. So 1 would be full weight, 2 should be double. And yes, it is. So for something like this, it's fairly predictable what we're going to get. For characters, you know, if you take a full blink and then overdrive that, you're going to get some nasty results. But it can work fairly well for, say, you want a slightly bigger smile, or things like that, or maybe an even bigger pucker, who knows, or a bigger puffy cheek. I'll stop making faces. Okay, so any questions so far? I'm going to dive into time samples now. If we just look at, just to clarify here what's going on right now, all we have, it's an array, but we're basically saying for all of these blend shapes, these are the weights that we want to apply. We can do as many of the blend shapes or as little of the blend shapes as we want to express here for this quote unquote animation. It's more of a pose. If we look at the blend shape USDA, that's what it looks like, right? Now we're going to do time samples, which is going to become this array of arrays, right? For every frame, we're going to define which blend shapes we're going to define which blend shapes we're going to manipulate at each frame. And so it could be multiple blend shapes at each frame. So I may extend the time frame, the timeline, but we'll see. Okay, so now we need to say I almost want to do this on a separate. We'll see what's the final sample that I create out of this. But for now, I'm going to separate them because maybe there's value in showing that you can do just a single pose like this. Okay, so we're going to just break this down by keyframes. So we're going to start at time code 1. So we're going to say frame 1. And all we have to do is just change this to include a time code. You can use the time code object, or you can just use a float number. So this is going to be 1.0. 1.0. And for this, I believe we want to set these to just 0. Again, in the real world, you'd probably have some animation already defined, and you'd loop through that and just translate those keyframes over to time samples here in USD. But for the sake of just understanding what's going on here and visualizing it, we're going to hard code it here. This is not going to be frame 2. We'll do 5. And we're going to go full isosceles. Okay. Then at 9, we're going to add 4 for every. We're going to do every by 4 frames per animation. Then we're going to bring isosceles back down. Sorry, this needs to be, I need to up these frame numbers every time. Then we're going to go right. So this needs to go to 13. And I'll probably mess this up on purpose, and then we'll fix it. Yep, at 13 we go fully right. And then at 17, we'll go isosceles full. Okay. And feel free, if you spotted the potential issue here, my goal is to start with equilateral, stretch to isosceles, equilateral, stretch to right, and then stretch to tall right. Let's see what we get. We can look here now at how this was encoded. We have time samples for the blend shapes. At frame 1, we're manipulating right and ISO, then ISO, ISO, right, ISO. And then this is correct. So 0 for both, then a weight of 1 for the ISO, 0 for ISO, right gets a 1, weight of 1, and then at 17, we bring in the ISO again. And then these are going to linearly interpolate between each of those keyframes. We get that automatically. Great question. Create the imaginable. That's for you. You're ahead of me there. So there are, by default, most you could do held or linear for your interpolation. I think for the most part, everybody does linear. If you have very strict, like if you want to do cubic curves, what you would typically do is set time samples for every frame to maintain that cubic shape of your curve. So in the real world, you would not leave this up to linear interpolation. You would probably keyframe every frame. I don't know of any plans to introduce for time samples. There probably isn't any plan to introduce other interpolation. But what is coming down the pipe is the animation curve schema. So that would allow you to more sparsely define your animation keyframes. So there's a proposal for that already. So we ran that. Let's go ahead and see what it did. And I didn't up the end time code. We want to end at 17. Okay. So here we are. No animation. Nothing whatsoever. We did bind the animation. And this looks correct. Token and float values. And it's interpolating them. What did I miss here? There was, do I have the skeletal API on each of these? Skel anim may need, this one has it, that one has it. I don't think I need that here, but just in case, as a sanity check, because I had that issue with the arm not animating recently. That looks correct. And I thought the animation can go anywhere, but let's go back to how the sample had it, which is it did that. And this needs to go to morphing. Scale anim. Let's try that one. No, I wasn't supposed to run that. One more time. Nope. That looks correct. Let's take a look at the sample. Finding blend shapes. Blend shape targets, I did that. I have scale and anim, and that is a 1 frame. I may need to define all the blend shapes every time. That could be it. Let's do that as another sanity check here. I thought you could do it sparsely, but all right, let's try this one more time. Sometimes it's just easier to edit the values, but that doesn't seem to be doing it. And let's try an older version of USD view just in case. It's probably me, but sometimes I wish it's not me. Here we go. Give me my triangle. Nothing, right? All right, let's take a look here. See if I missed something. So this is interesting. One thing that I see here from another example that I have is that they only defined the blend shapes once. And then the animations, and then the weights are animated. Let's try that. There we go. That's what it is. Makes sense. Does the doc say that and I missed it? Given a skinnable primitive, I'm looking for blend shapes and blend shapes weight. And this is defining more blend shapes that are actually used. Okay. Okay, so I think if you guys are all reading this as well as I am, it's kind of implied here that they defined all of the blend shapes, even though they're not animating all of them, or even though, for example, this mesh doesn't define all of them, because this is no, I don't think you could reason through that. I think that needs to be more explicit that this attribute should not be animated and this one should. So let me make a note of that. All right, and now we can fix this. So, so I agree. I do think we need, it'd be great to have more complete working examples in the documentation. The good thing about the OpenUSD documentation is that that is also open source. So, you know, I'm doing this because I want to improve that, but, you know, I hope I'm not the only one, and it doesn't sound like I'm the only one that would like that to see that improved. So here in the docs is some of this documentation. The area that specifically where I'm reading, I believe, yeah. Nope. Doxygen Python. It's not gonna, it may be generated by, yeah, it's likely generated by the Doxygen. So that would be UsdSkel. So you do need to go into the code, but it's all just doc strings. Where would you be? Which would be the one that, so here's the skin, there's the Skindarm USDA, and here's the documentation for, this is the overview. So you can totally come in here, make the changes you need, and contribute back. So please consider helping us out. And, you know, I can't get to all of it, so I hope at least by working through this live, you get enough of an idea of how it should hopefully work, and contribute that back if I can't get to it. Okay, so we're coming back over here. What did we learn? We learned that we're only going to set this once here, and then for every frame, we need to set all of the blend shapes. So less sparse than I had hoped. Let's try this again. So we're going isosceles first, then we're going back down, then we're going right, and then we're going both full. So this is going to solve the ambiguity that I was setting up and was actually going to make it not work. But in this case, it's going to work correctly the first time. All right, so here we are. Equilateral to isosceles, down to equilateral, to the right, and then up. And that's it. We can play it back. It's like a little dancing triangle. Cool. I think we could even, so I've split this up into two different samples, the blend shape and the scale. I was thinking it'd be nice to have one full one, which would be like a bowing cube with a little triangular hat or something, just to combine both of them and see that all working together. So hopefully I can get to that. That is it for what I wanted to show. I don't think we need, well, the comments don't hurt. Okay, so sorry for the confusion a little bit earlier. This should not be animated, the blend shapes list in the animation. You list all the ones that you want to animate, and then time sample the weights after the fact. One thing that I do wonder is, does this work? It should work, right? Say for this animation, I only want to animate one blend shape. I shouldn't have to list all of them, right? That would be a good thing to mention here if it is required. Doesn't look like it. So you can, an animation can sparsely list the blend shapes that it wants to animate if it doesn't need to animate all of them. But once you've committed to saying, I'm going to animate both of these blend shapes across my animation, across this animation, you have to list them all at the beginning and then also set values for them at every keyframe. Cool. So let's, we've got 15 minutes. Let's go ahead and take a look at the extent issue. I am curious about defining an extent on the root and if that would have also solved my issue that I ran into last week. So for that, we have to look at the API. That didn't take me where I wanted. Let's get to the current. I want to go to modules. Nope, classes. And we're looking for UsdSkel. Skel root. What does Skel root have? It does have boundable. So I should be able to define an extent on this. So, so let's do that. All we have to do is move this function call from the mesh to the Skel root. Blah, 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 blah. Where am I? This one. Okay. And here's our Skel root. Now, we'll test this out and make sure it works. Oops. Let's just go ahead and move this up here. I'm destroying this code now. Okay. And then we reload, reopen stage, and it still works. In fact, it even framed it better this time around. I really like that little dancing animation. So that worked out really well. And so consider that when you apply an animation, you're also likely going to want to apply the corresponding time sampled extents that for that animation. I suppose you could have one value that just encompasses all of it, but ideally you would have the time sampled bounding box for every to match that animation. So it is a good thing to set it on the Skel root, because if this is the thing that's being instanced, you can change this without breaking instancing. Should we do that? We do have time. It's not going to be very interesting. So basically what we're going to do is kind of based off of this animation, figure out the bounding. Let's try it. In fact, I think that I should be able to show. So that's showing the bounding box, right? Yeah, look at that. So this is actually this dotted line is actually showing the bounding box. So it fits perfectly with my default shape. But as you can see, as it animates, this is like a whole another live stream that we should do. It's just talking about extents. You can see that as it animates, you can see here that the height difference between my my right triangle and the equilateral triangle. So that's cool to see. As it animates, you can see that that bounding box is not changing. And so our goal is to get that to change so that this will be a visual representation confirming that the extents are correctly encoded, so that if we run it something like pruning based off a bounding box, imagine I have a shot, and in this animation, in this shot, this little corner of the triangle pops in. And I really wanted to see that, but I run my camera pruning and it prunes everything that's not in the view of the camera. And when it does that, it's going to come over here and be like, oh yeah, this bounding box is totally not in the view. And so that triangle would get left out. And then I'd scratch my head and be like, where did that triangle go? I was looking at it in Maya and it's there, I see it. Why isn't it showing up? And so our camera pruning algorithm would have cut that out, rightfully so. So, so there's our extents, and I'm going to encode this as a dictionary, and we're going to say the very first one is this one. Then at frame 5, we're going to isosceles, right? So we're going to do what did we do for isosceles? It's where is that blend shape? This one. We're doubling the height. Okay, we need commas here. And then at 9, we're going right back down to equilateral. 13, we're going right, which is, we'll figure that out in a moment. And 17, we're going so we're adding that much to the equilateral. So this is a mess, but it's going to work. Okay. That's parentheses aren't required there, but it keeps me sane. And then this one is going to be 2 times the height. That's going to be our isosceles height plus the little bit of right triangle business here. Okay, and we don't need that there. And so now we should be able to say for frame in time sample in extents anim, we should create the adder and then set it. And the little optimization here, I mean, it's technically not wrong, but or not, it's not going to hurt, but it would have been better to just get the create the attribute once and then you reuse that. So little improvements that I should do for the final sample. This is going to be called extents adder, and then we're going to set it. I think there's a performance impact, if I remember correctly, for calling create a bunch of times like this. And we're going to set it to, this is time sample and value items. So this is the value and time sample. Okay. Nice. So we can see that bounding box growing with our animation. And maybe we got lucky here with the interpolation. You may want to set a value for every time sample because I guess you can't trust the interpolation to fully cover your object using linear interpolation between those values. But it worked out here. Cool. So now when I'm over here, I'm gonna my algorithm's like looking at this here, and now it sees if I'm clipping based off of, or culling based off of bounding boxes, now this bounding box would hit, and this character would be spared. Cool. All right, I'm glad we got that in there. I do think it'd be an interesting live stream to go over extents in more in depth. But there we go. I really like watching that. Okay, that's it. We finished a little early today. We didn't really have that much to cover. Should have taken less time. But thank you for sticking with me on this. If you have any questions, please feel free to ask. I'll stick around a few more minutes if there's anything else. Yeah, sorry, I missed that question, but thank you for asking it again. So do blend shapes use the scale and bones and weights to do the transformation? No, those are completely not accounted for in this. As we can see, I didn't define any joints for this. This quote unquote character is fully defined by the blend shapes. The deformations are fully defined by just the blend shapes, and I'm defining those blend shapes purely by the default mesh, which is this one, these points of the equilateral triangle. And then for every blend shape, I'm setting how much I want to push the points on that mesh. And I'm saying get the point at index 1 and offset it by an additional equilateral triangle height. So now it'll be double the height. So that's what's going on there. If you have a character with, say, bone animation and blend shapes, and there some vertices are affected by both, which is possible. Yep, it's all point interpolation. Traditionally, that's all that blend shapes are. But if you have a vertex that is being influenced by both bones and a blend shape, then I thought there was some math here. Let's take a look at this blend shape. Initial point of the blah, blah, blah. Oh, in-betweens we didn't talk about in-betweens, but in-betweens are also a thing. I think that's maybe out of the scope of this, but basically in-betweens you can define for a blend shape, you can define in-betweens and basically say at a weight of some intermediate weight, I want you to use this shape instead of interpolating between neutral or, for example, open eye and the blink. For the mid blink, I want to correct that shape and maybe pop out the eyelid a little bit more to fully wrap around the eye. So you could do that with defining a shape for that middle weight, and then it will interpolate between the open eye to that middle and then back to the closed. So have a look at that. I thought there was another joint influences. Have a look here. If it doesn't, I want to say that it does the joint and deformations first, and then it does the blend shapes after that. It adds them together. Here we go. When a mesh is skinned, blend shape application precedes the effect of skinning using joint. Oh, sorry, I got it backwards. So it'll do blend shape application first, and then it'll do the skinning using joint transformations. So P is the initial point of, say, the cheek, and then you would do your blend shape animation to maybe puff it, and then if a joint happens to then influence that, it would then, after this P prime, it would then apply that transformation as well. What is my GitHub repository? Good question. Omni code with me. I'll push that up as soon as we're done here. So that'll be under scripts. There will be one for blend shape. The Skel one is there already. Okay. We'll see what I decide to put into this documentation, and hopefully it gets accepted. The merge request gets accepted, but additional examples I may put into either a tutorial or in the Omniverse docs, we have the code samples. And so we'll probably have an animation or Skel section here, and we can add more examples here. So if you haven't checked these out, we have examples of, something that you might be looking for. Oh wait, how do I check if a prim exists? Well, here you go. So if you haven't used that, hopefully you find that useful. And great, we made it to the top of the hour, or we started a little late today, but we made it for the full hour. So thank you for coming. I hope you learned something. I know I did, and I hope that you guys continue to learn more about USD. And if you have any questions, please let me know. You can reach out to me offline. I'm on Discord at the Omniverse Discord, and we can talk offline. All right, have a great week, and tomorrow we have a really great live stream with Moment Factory, NVIDIA.com, Omnivores. No, almost there. Here we go. Designing immersive events with OpenUSD and digital twins. So they're doing kind of virtual production, live events type of stuff using USD and Omniverse, and it's really interesting. Eric's got his live stream of designing and engineering design in Omniverse, and then developer office hour on Friday. So try out some of this UsdSkel stuff, and if you have any more questions, you can always come on Friday and ask them there. All right. There's a link. All right. See you, everybody.